Hello. In this video, I'm going to explain how to design and simulate a digital logic function using Logisim. Here, I already have an expression. I will read it. So f is our output. F is equal to A nor B, ANDed with C, ORed with C naught and D. So here we have what looks like an OR gate with a bar on top of it. We can use an OR gate with an inverter, or simply use a NOR gate, a two-input NOR gate. Another way to write the same expression is instead of using the bar on top of the plus sign here, we're going to use brackets and then a dash at the end. But the expression is exactly the same, but it's written in two different ways. Before we start sketching the schematic, we need to know the priorities of operators. The operator with the highest priority is the bracket. It's not really an operator, but it's an indication that whatever is inside the brackets must be performed first. What comes next is the NOT gate, and then the AND gate, and finally ORing and XORing have the least priorities. I did not list the NAND gate or the NOR gate or the XNOR gate, but they simply fall into one of the categories here. Or since we can write the NOR gate using brackets like this, we can assume that the bracket has the highest priority, but it's actually a NOR gate that we can simplify. It's OR with a dash. So let's start by first placing the inputs that we need. We have A, B, C, and D. That means we have 4 inputs. I'm going to place 4 different pins. Remember, the square pin in Logisim is the input. And I'm going to click now on each of them, and then under label, I'm going to change the settings by labeling each pin that I have. I have A, B, C, and finally D. It doesn't matter whether I'm using C naught in my expression or not. In all cases, C is the input, and then I will need to use an inverter to obtain C naught. So let's start by first connecting the NOR gate. I need to find A nor B. So I'm going to place the NOR gate by expanding the gates group and then selecting NOR gate. By default, I have a 4-input NOR gate. You can check here that the number of inputs is 5. Since I only need a 2-input NOR gate, I'm going to change the settings to 2. So now I have a 2-input NOR gate that takes A with B as inputs. Okay. This output, I can extend a wire from it and then place text just to help me with the labeling. I'm going to say this is A nor B. Okay. A nor B, which is all of this, is ANDed with C. So I will need a 2-input AND gate. By default, again, it's a 5-input AND gate. I'm going to change that to 2 only. Okay. This AND gate takes A nor B as my first input. I will just move things around to ensure that they're actually connected. And the second input to the AND gate is C. So I did the first half of the expression. The remaining half, I'm going to leave the plus sign for later because OR has the least priority here. I need to perform ANDing first, or actually the NOT gate first, not C. So I will need an inverter. I don't have to worry about the number of inputs for the inverter because they're always going to be 1. I always have, for the NOT gate, you cannot have a 2-input NOT gate. It's always going to be 1 input. This NOT gate takes C as an input. Okay. I'm going to extend the wire from it just to help me with the labeling. I'm going to say this is C naught. Okay. I now have C naught. I need to AND it with D. So I'm going to use a 2-input AND gate, change the number of inputs to 2. The first input of the AND gate is C naught. The second input is D. I can change the size of the gate just to help organize things for me. So C naught ANDed with D. Now I have 2 gates towards the end. This gate is actually A nor B ANDed with C, which is what's on the left side of the plus sign here. And this second AND gate outputs for me C0 ANDed with D. Okay, all I need to do now is simply OR them together. So I'm going to place an OR gate, change the number of inputs of it to 2, and then connect this part first. I'm going to change the size of it again to narrow, so it's more neat. And then remove this extra wire, and then finally connect the second input. This is going to be my output. So I'm almost done. I'm just going to connect an output pin here. Okay, from the OR gate to the output pin. And I will label the output pin from its settings as F. F is my output according to the expression. So I'm going to click here, type F. Okay, now I'm done with the connection. In order for me to test it, I need to ensure that simulation is enabled from the simulate menu, and I will have to click on the this button right here. This will allow me to change the values of the input and fill in my truth table. Now all the inputs are 1. When all the inputs are 1, the output is 0. Let's see a combination that will output a 1 for us. So this is one of the combinations that output 1. Remember here I used A, B, C, D according to this order, in this order, but in the truth table I might have A on the left side, so be careful or pay attention to the order of the inputs and compare them with the order of the inputs in your truth table before you record the output.